We will solve the following exercise. Exercise 2.52. The total weight of the man and parasail is W equals 230 pounds. The drag force D is perpendicular to the lift force L. If the vector sum of the three forces is 0, what are the magnitudes of L and D? Okay, so once again, I'm going to solve this exercise. I'm going to first solve it, then explain what was needed for me to solve it, because I know that some of you just entered this video to see how I solve the exercise directly. Okay, so we are going to start by doing a free body diagram. Right here I'm going to have Y and X, Y, X. Right here I'm going to have L, D, and W. Okay, the angle between L and D, as the statement says, is going to be 90 degrees. Okay, and the total weight of the man and parasail, W equals 230 pounds. The answer that I should look for is L and D. One of the most important parts of the statement is the summatory between the three forces is equal to 0. Okay, so first I would like to determine this angle. The reason why I want to determine is because of this. I need an angle for me to develop the exercise. So 5 and 2. I'm going to draw once again. Bear with me. The triangle right here, 5 and 2. And I'm going to determine this angle. Now, I'm going to use the cosine's law. It's been a while since I don't use it. You can use whatever you want for you to determine this angle. You can use different trigonometric identities to do so. So it would be 5 squared equals 2 squared plus the hypotenuse, which I'm going to call x squared minus 2 times 5 times, 2 times x times 2 multiplied by the cosine of the angle right here. Now 5 squared is equal to 25. This is equal to 4 plus the square root of x squared. But first I have to determine the hypotenuse. X is equal to 5 squared plus 2 squared. 5 squared equals 25 and 2 squared equals 4, which means that x is equal to the square root of 29. The square root of 29 to the second power is equal to the same number, so plus 29 minus 2 times the square of 29 times 2 times cosine of alpha. Okay, now 25 equals let me see, I'm gonna have to multiply this first. So 4 plus 29 minus 4 times square root of 29 multiplied by the cosine of the angle. Now I'm gonna have to do the following thing. Cosine to the minus 1 power is equal of 4 plus 29 minus 25 divided by 4 square root of 29 equals alpha. Okay, now cosine to the minus 1 power of 4 plus 29 equals 33 minus 25 equals 8 divided by 4 square root of 29, and this is equal to alpha. Okay, alpha, I'm going to determine using the calculator, is equal to shift cosine to the minus 1 power of 8 divided by 4 square root of 29. Okay, the angle is equal to 68.1985 degrees. Now I have the angle, which is this angle, to use blue, which is this angle, but I don't want to use this coordinate system. Why is that? Because I have to decompose 1 and 2 forces. If I change it, or if I rotate the coordinate system 90 degrees, I'm going to have y right here and x right here, which means that I'm going to have 2 forces along the 2 axes and just 1 force to decompose. Okay, so I'm going to create a new axis right here, which is going to call y prime, and right here I have x prime, and right here this is it. Now the angle that I have right here is the same angle. I'm sorry, that is not correct. The angle that I have right here is this angle. Okay, because this is a straight line and this is in a straight line. So because it is the opposite angle, I can say it's the same. Okay, alpha and alpha. Now we will start solving the exercise. Let me move this. Please bear with me. Yeah, right here is okay. Now, summatory of forces along the x prime axis right here is going to be positive. Along this direction is going to be positive. So minus z plus cosine or sine, in which case I'm going to use sine of alpha equals 0. I'm sorry, sine of alpha multiplied by w equals 0. Now, summatory of forces along the y prime axis along this direction is going to be positive, which means that I have L minus W cosine of alpha equals 0. Okay, I have 2 unknowns. Since I have 2 equations, then the exercise is solved. Remember that if you want to solve a specific amount of unknowns, then you must have at least the same amount of equations. Okay, so in this case, D, which is the drag force, is going to be equal to W sine of alpha, which is equal to 230, I think. Yep, 230 multiplied by the sine of 68.1985. Now d is equal, I'm going to save this number within the calculator's memory. For me to do so, I have to press shift storage, and I can save it within any of these letters in red. I don't know, I'm going to save it, for example, in Z. For when I look for Z, the calculator is going to tell me the answer. Now, Z is the angle. Okay, so 230 multiplied by the sine of C equals 5496, and this is in pounds. Now L is equal to W cosine of the angle. Okay, in which case I just have to change this trigonometric identity for cosine. 85.4198 pounds. And that's it, guys. This is basically how you can solve this exercise. Now, there are some things that I would like to point out, some hints that I would like to say for those of you who want to stay. First, during a test, this is a waste of time. Okay, you don't have to draw a second time what you were already given. Okay, you were already given a diagram. Okay, I could have just start drawing my forces right here, my axes, my change of axis, the one that I did, and I wouldn't have to draw again to use more time that the one required for me to solve the exercise. I know that the time is a key factor for when you are doing a test. Okay, so my recommendation is use what you are given. Okay, now something else right here. I wanted to use the cosine's law. It is not really complicated, but it's been a while since I don't use it, as I mentioned before, so I wanted to remember how to use it, in which case it is really simple. I'm going to take a moment of this video for me to explain it. You just have to use the opposite cathetus of the angle that you are looking for. Okay, in this case I'm looking for alpha, in which case I'm going to use 5, which is the opposite cathetus. The opposite cathetus is going to be equal to the other two added together, each squared, minus 2 times, once again, the other two cathetus multiplied by the cosine of the angle. Okay, I know that in this case it would be easier for you to use I don't know, maybe a sine or cosine for you to determine that, but the sine and cosine's laws are really important in trigonometry. And that's pretty much the reason why I did it. Now, this is important as well. Okay, this notation, because it is telling the reader someone that could be the professor or someone else, that I'm going to consider every single one of the forces pointing towards this direction positive. Okay, that's what I'm telling right here. That's why D is negative, because it's pointing towards the opposite direction. The same thing goes right here, and once again, this is not mandatory. The change of coordinate system, the way I change it or I turn it, I rotate it 90 degrees. I could have, I did that because of this. Okay. Basically because of this, because right here I'm going to have a 90 degrees angle. But I could have just basically continue with the same two axes, the axis that we always have used, but in which case I would have to decompose the L force, the one that goes right here and the one that goes right here. Okay, this is multiplied by the cosine, and the other is multiplied by the sine. Okay, and once again, right here and right here for the other force. And W is going to be just one force along the y-axis. Okay. That is pretty much it, guys. That is what I wanted to show you. There are some different things with the calculator. I tried to solve the angle using the calculator with the solve option, but I don't think that it's a good idea because it could be confusing for some of you. The calculator is going to show a lot of different results for when you want to look for the angle. Okay, for example, if you put this equation, let's do it, why not? 5 squared equals 2 squared plus x, which in this case is 29, minus 2 times square root of 29 times 2 times the cosine of the angle, which is the unknown. The unknown is usually x. Okay, so once I have the equation with this type of calculators, specifically some others of course, I should be able to determine the unknown, because right here I have an equivalence. So I'm going to press Shift Solve. Yes, I want to solve it for x, but okay, let's try it. Let's give it a shot. As you can see, it's showing 1371.80, 1409, etc. This is a valid answer for the angle. Okay, so what is happening is that, of course, the circumference uses 360 degrees. For example, let's assume that the answer is this angle, which I'm going to call alpha. What is happening is that the calculator is going to show a result in which this equivalence or this requirement is met. Okay, so if the calculator finds a number for x, and that number within this part of the equations happens to be equal to 25, the calculator is going to show the answer. Okay, But what happens if there is multiple answers for the same equation, like in this case? Why is that? Because yes, right here we have the answer, but what happened with this angle? Okay, it would be in this case 68.1985 plus what we have right here. Right? And this angle is as well valid for the equation. And what happens for this other? And what happens for this other? Okay, so that is actually what is happening right here. Now, the number, shift solve for x. The number that I put right here is the first iteration, the first calculator iteration. Okay, so the calculator is going to try with 1. It is going to check, okay, this equivalence is met. No, okay, try with the other, with 2, with 3, with 4, and at the end it's going to show the first result it finds. Okay, but for example, what if I put a 5 right here, which is the first attempt that the calculator is going to try? Equal is going to show 428.198, etc. What if I use shift solve, I don't know, -6? Okay, so the answer closer to that result is 291. Now, it doesn't work like if I put, for example, shift solve 68.1985. Let's give it a try, or I don't know. Okay, it is showing me the result because it is telling me like, okay, the result that met the requirement closer to the number that you just put is this one. Okay, so please do not be confused with the calculator if you are going to use it that way. And that's pretty much it, guys. This is how you can solve this exercise.